Sharing. Yeah. So this is going to be my notebook for the day. And this is a Kaggle competition which happened last year. This is a computer vision Kaggle competition. A quick statistics like how many of you already know TensorFlow? And how many of you already know computer vision? You can put TensorFlow, yes, computer vision, yes, or computer vision, no, TensorFlow, no. You can put something in the chat so that, I can tune my session accordingly. There are 9 of us here, so you can just quickly put it on the chat window. Like, oh, I know only English. Yeah, SCV, STF. Okay, one person doesn't know. So mostly you're familiar with TensorFlow. Couple of them I've answered. And so I'm just going in a medium phase. So, if there are people who don't know TensorFlow, you'll have to alert me so that I can go slow. Since the couple of people have answered, they know both computer vision and TensorFlow, I'll go a bit faster. And so this has been a competition which happened last year. Yeah. So so this competition is about computer vision, particularly image classification competition. And so the main objective of this competition was to classify if the images has got melanoma lesions or not. So this is a problem statement. You've got images this side which has melanoma lesions, and this side you have images without melanoma lesion. So this is a binary classification problem, image classification problem, where you'll have to classify if a particular image has got melanoma lesions or not. So this is the problem statement. Let's go back to who's organizing this problem statement and all that. So there are a couple of organizations. One is the SIIM and the other is the ISIC. These are two research organizations which have collaborated together and to organize these competitions. Both of them have the same goal. They want to reduce the mortality of melanoma, people dying because of melanoma. And so they don't want to bring down the mortality rates of melanoma death. This was the common vision for both these research organizations. One particular thing you have to know about International Skin Imaging Collaboration is they maintain a huge repository archive of melanoma images and all the skin image classification repository. It's a publicly available repository for research purposes. And the Society of Imaging Informatics and Medicines, they organize a lot of, they collaborate with academicians, research organizations to bring together some innovative research. And so these are two organizations. This is about the host who is conducting this competition. So we have seen the problem statement. We have seen who is organizing this competition. Let's also, since we have already seen the problem statement, let's look at the data. If you go to Kaggle competitions, you'll have several tabs. One of the data tab is here. And so here you have what is the data which we have. So we have a sample submission CSV file, which will tell us how to make a submission to Kaggle. We have test CSV file, train CSV file. And this is a metadata about the patients. You have additional metadata like, the image name, patient ID, and gender, age, and all these additional metadata is there in the CSV file. But if you come here, you have the train and the test. And you also have TF records. So TF records, these are like binary storage format from TensorFlow T. And so we will be using the TF records. You can also use JPEG format or, the other format, DICOM format. You are free to use any of these format. But since we're using TensorFlow ecosystem, so we'll use TF records, which comes from the TensorFlow ecosystem. It's TensorFlow's binary storage format. You can convert anything into TensorFlow, anything into TF records. And so we'll also be covering a little bit about TF records in the notebook. This is about the data set which we have. And we've seen the data sets now. let's go through the notebook. So we have seen who's organizing this competition and what this competition problem statement is and why should we even care about skin cancer. So there's a lot of deaths because of skin cancer in US alone. This is a statistics from US, and there are almost 100,000 people diagnosed with skin melanoma in 2020 alone. And per year, an estimate of number of deaths because of melanoma was 7,000 in just US alone. That's a huge number. When you take up worldwide, it's going to be even huge. And if you take up developing countries, it's going to be even huge. And so this is a very, very important problem statement, and there's a lot of deaths because of this. So computer vision can really help in automating or diagnosing melanoma a little earlier. So diagnosing it earlier is very crucial, because if you can diagnose it earlier, there's a lot of probability the patient can be cured. But at later stages, if the melanoma is diagnosed, then there's a lot of probability the patient may not survive. And so this is why it is important to diagnose it early. And this is the context of the problem statement. Now let's get into the TensorFlow code. And we have seen the data sets, and we're going to use a pre-trained model called EfficientNet. And so this part of the code is we are importing all the packages which is required. We are using TensorFlow, and we're using the EfficientNet and all that. And we are also going to use TPUs. So you can also use GPUs, and you can also use TPUs. You can use any runtime accelerator you like. But the reason why I chose TPU is, again, because it's all TensorFlow ecosystem. So TPU comes from the Google ecosystem. So I thought of using TPU. And so this is TPU. If some people, I think most of you would have used Google Colab. So if you have used Google Colab, you might be familiar with TPU already. And TPU is Google's custom application specific integrated circuits. And it's much more faster than GPU for certain kind of operations. And there has been a metric which calculates, and all of us are already using TPUs because almost everyone will be using the Google application suite of products, and all these application suite of products from Google, they run on TPUs. And so Google initially developed these TPU to accelerate their production and their product developments. But in 2017-18, around that time, they had actually made it, they made it available through Google Cloud Platform. And they've also made it available through Google Colab. But it's outside Google Colab platform and outside the Google ecosystem. You cannot buy TPUs. Like, you can buy NVIDIA GPUs like RTX 3090 or A100s or whatever, but you cannot buy TPUs like that. You'll have to depend, there's a dependability on GCP platform, and you cannot get TPUs in AWS and Azure. It's very, very specific to Google. That's why it's Google's custom developed application specific integrated circuits, because it's specific to Google Cloud. And you will also have access to TPUs in Kaggle. You will have access to TPUs in Google Colab. And this is about TPUs. A little statistics on, if you have never used TPUs, just in case if there is even one person who has never used TPUs before in this room, then, little statistics for you to get an intuition of how fast a TPU can be. So if you have to train ResNet 50, and this is a comparison between, TPU V2 pod and 8 V100 GPUs. So it is a TPU pod in comparison with 8 V100 GPUs. It is 27 times faster training, and the low cost also is very low. And there is little less, cost involved, and power consumption is also very less compared to GPUs. And so this is a little small statistics about how fast the TPUs can be. So yeah, So if you're going to use TPUs, then there is a certain section of code which you need to block of codes which you need to include in your notebook. There are a lot of people who have joined now. There's 17 of us here. I don't know when you have joined. Are you all able to follow the class? Is it too fast, or if you can put it in English, if it is too fast, or are you able to follow? Should I go slow? Anything like that?
I think you okay. I am able to follow with you. Yes, there is a lot of people joining right now, but it's okay. You already mentioned that you important the libraries, and this is the TPU overview. This what has been described by Usha already for those that will join us. So yeah, you can continue. Yeah. Thank you.
Yeah, sure. So if you want to use TPUs, first in Kaggle, you will have to change your accelerator to TPU. In Kaggle gives you TPU V2 port, V3 port, and which has got 8 cores, I think. So this particular piece of code which you're going to include here is first step involved in connecting to TPUs is first you'll have to find a remote cluster which is available. Once you find the remote cluster, you will have to connect to the cluster and you'll have to initialize it. And there's also an abstraction layer. So if you see TensorFlow has got a lot of distributed training APIs. So these are abstractions which will, save you a lot of time. You don't have to sit and write all this lengthy coding, how to do distributed processing, parallel processing, and all that. You don't have to worry about it. All of this is taken care by this distribution training API, and that is called TF distribute. So TF distribute has got a lot of methods, and for TPUs specifically you have something called TPU strategy, and there are several other strategy methods available out there as well. You can go to the documentation and you can check this out. I'll just go and I'll show you. So distributed training with TensorFlow, and so you will have several APIs, but we will be using only TPU strategy because we are going to connect to TPUs. But then you can check out the other strategies available outside. What the mirror strategy, multi-mirror worker mirror strategy, central storage strategy, what each of these abstraction means and what they can do and what they don't support, and all this detailed documentation is available in TensorFlow documentation page. You can go and you can check out the different types of strategies. But for TPUs, it's very simple. If you're going to use GPUs, and maybe you might have to think and choose the best strategy. But for TPUs, it's very simple. There's only one which is available, which is tfdistribute.tpu strategy. So first you'll have to find a cluster, remote cluster, which is available, then connect to the cluster and initialize it. And then, you don't have to deal with TPUs. You don't have to write that low level coding and all that. TensorFlow is a high level API. So you don't have to bother about how to operate TPUs and how to, do the parallel processing, and all of it is taken care of by the TF distribute API. This is an abstraction, so you don't have to do any low level coding. So this is what this piece of code does. So any Kaggle competition, if you're going to use TPUs, you can just blindly cut, copy, paste, and paste it, because the code remains is going to be the same piece of code across every time. So first you'll find this piece of statement, TF distribute cluster resolver, TPU cluster resolver. First you'll find the remote cluster, and then you will connect to the cluster. This is a statement for connecting to the cluster. And then you will initialize it using the statement TF TPU experimental initialize TPU statement. And then you will create a TF distribute experimental TPU strategy object. And this is the object which you will be using to reference TPUs in your code. And so this Kaggle contains TPU Kaggle contains, V3 pod. So V3 core, contains 8 cores. And this is about TPUs. And at the time when I wrote the notebook, there was a constraint that if you have to use TPUs, then your data set has to be present in Google Cloud Storage and all. I'm not sure if the constraint still exists, but so that code is written like this. And so Google Cloud Storage, in order to access your data from Google Cloud Storage, there is an API in Kaggle which you can use it. It is Kaggle datasets.getGCS path will help you get your data from the Google Cloud Storage. That is the purpose of this particular API. And we also have something like tf.data.experimental auto tune. So we're going to see a lot of high level APIs. And so we first saw about TensorFlow part of code. So the TPU part of code. So the TPU, there was a block of code which does this initializing, connecting to TPU and all that. So if you have noticed, we did not write any low level coding there. So it's very simple. You just have certain methods which you initialized and created an object. And the same way, we're going to see other APIs as well. One such API is going to be TfData. This TfData will take care of your input pipelines, and you don't have to write low-level code. It will automatically take care of your input data pipelines. In next few minutes, we're going to see how to use this TfData. But this auto tune specifically is for, there will be certain parameters, which instead of explicitly mentioning, you can actually choose the best parameter value dynamically at the runtime. So that's why you choose auto tune is equal to TfData experimental auto tune to choose the best parameters dynamically at runtime. And so these are just few parameters like batch size. So batch size is 8 strategy.num replicas. See, the num replicas.sync is going to be the number of cores your TPU has, which is 8. And so 8 is 64. So the batch size is going to be 64. And the image size here in this particular problem statement is 1024, 1024. So far we have seen about TPUs and how to initialize the TPUs. Even if you are seeing TPUs for the first time, don't get overwhelmed. This is a piece of code which will come every time. And so the next piece of code is about TF records. So we're going to see everything related to TensorFlow ecosystem. And so we saw about TPUs, now it is TF records. TF records, I've already shown you the data set. We already have data set in the form of TF records for this particular problem statement. So if you go to the data tab, you can see the day you have TF records already given to you, but in several problem statements, Kaggle computations, that may not be the case. You may have to create TF records, but Kaggle has got a lot of sample notebooks for you to guide you through the process step by step. And so TF records is TensorFlow's own binary storage format. Again, there's no such restrictions like you shouldn't use. You also have, if you notice the problem statement, you also have it in the form of JPEG. You also have it in the form of DICOM format. You can go ahead and use these formats for solving this problem statement. But TensorFlow TF records sits well with the TensorFlow pipeline and the ecosystem. It sits really well. And so, a lot of processing might be faster, it might be efficient. And also for all those performance related reasons, I'm using TF records. But TF records is not the only option. You can also use the DICOM and JPEG formats, which is given to you. So anything which is available that can be decoded in TensorFlow, it can be stored as a TF record file. It's just a file format. And more about the file format, how it looks like and all that, you can go to the documentation and read a lot about it. And so since we have the data already in TF record format, we don't have to do anything. We're just, taking the data set, splitting into test. You already have training and test set. I'm just making one more split: training, validation, and the test set. So now I've taken my TF records and I've split into training, validation, and the test buckets. So this is what this piece of code does. Now we have seen TPUs, we have seen TF records. Now we are going to see the third part, which is making your input pipelines. So for solving this problem, I'm going to use a pre-trained model, which is called EfficientNet. But see, EfficientNet is one of, it got released in 2019 from Google Research. And it's one of the very high performing architectures when it comes for computer vision, and a lot of Kaggle competitions. If you see the winning solutions might have used EfficientNet in some way or the other. So it's a very popular architecture as well. So your modeling part and all is very strong. Then what about your input pipeline? Is your input pipeline as efficient as your modeling pipeline? That is something which you need to pay attention to. So you need to have an efficient input pipeline, which is equally performing well in comparison with your model. And so TensorFlow ecosystem makes it very simple. They have an abstraction for building input pipelines as well. That abstraction is called TfData. So why it is important to use this diagram speaks for itself, why it is important to use an abstraction like TfData. So if you're not going to use any such pipelines, or any such abstractions, you're just doing the processing the data and feeding into your model without doing anything, then the first diagram, there's going to be a lot of idle time and it's not going to be efficient. The second time thing is where you use some abstraction like TfData to do parallel processing, and you can see the reduction in the idle time. And not only that, it's also for the ease of use. If you see TfData, it saves you a lot of low level coding. You don't have to sit and write a lot of low level coding. A lot of things is taken care by with just single function call. You can accomplish a lot of things. And so TfData is a very, very handy API for handling your input data pipelines in TensorFlow. So now let's go and see how to do this in TensorFlow. So a little thing, few things you will have to be very familiar with is this TfData API. Is you have something called tfdata.tfrecord dataset. What this particular function does is it takes a TF record as an input and it will convert it into a TF record data set. And once you convert into a TF record data sets, you will get access to a lot of methods, which you can do a lot of transformations. You can convert from one form to another. You can do a lot of things. So this job of converting a TF records into a TF record data sets is taken care of by this function. And there are a lot of transformations, which I told you. One advantage of using an API like TfData is a lot of transformations you can do with a method call. Like, you want to map, you want to apply a particular function on every element in the TF record, then you can call the map function. You can do batch processing by calling the batch function. You can shuffle, prefetch. So there are a lot of transformations which you can apply on this TF record data set. And so these are important points which you need to understand about TfData API. So you have this particular method, which is TfData TF record data set, and you can do a lot of transformations. And so this is about TfData API. So there are a lot of functions which I've written here. And so if there is one or two people at least who's not familiar with TensorFlow, and then if you want to understand there are a lot of custom functions which I would have written as well. So if you want to understand what is happening, this diagram speaks for itself. It is just the method call. And so you have one method, load data set. You have a method for training, validation, and test. So this is the load data set method. And you have methods like get training data set, get validation data set, and get test data set. And if you see these methods, get training, get validation, and get test data sets, it in turn calls several other methods. So get training data set is actually for first creating a data set. And it's calling a load underscore dataset method, inside which you will be creating a TF record dataset object. And once you get the TF record dataset objects, you're applying several transformations like map, repeat, shuffle, batch. The same thing happens in validation and test datasets. You'll create a TF record dataset object, and you will be applying several transformations here. So if you want to understand at the high level how the method call is, I've put this simple diagram which will help you understand how the method. So every method, get train, get validation, get test, is going to call the load data set method, which will actually create a TF record data set object. Once you create a TF record data set, this is what is happening in load data set method. And once you get a TF record data set, you will be applying several transformations here. So this is the workflow of this is what is happening inside all these custom functions. And so this is how we build input data pipelines in TensorFlow. It's going to be very easy because you're not going to sit and write low-level coding how to shuffle the elements in a TensorFlow TF record, or how to do map and all that. You're not going to write low-level coding. All these transformations can be taken care of, and this pipeline also sits well with the TensorFlow ecosystem. So this is about the TfData API. Then again, it's going to be about the data augmentation. So when you want about data augmentation, and why do we actually go for data augmentation? Whenever there is less training data, if you have labeling data is very, very difficult process. And so, not many times we might get, annotated data, both in computer vision and NLP. It's going to be a time consuming process. Getting the resources to label your data is a big headache. And there are a lot many times you may not get the data at all. So what do you do in such circumstances when you don't have sufficient labeled training data? Then there is a process called data augmentation, which comes in very handy. You don't have to go out and seek additional data. You can increase the size of the data with the existing data set itself. And how this data augmentation process does it is, it applies, it takes the original image and it applies several transformations on these images to create multiple images from a single image. This is the whole process of data augmentation. For example, if you take this butterfly, there is like a lot of transformation which is done. Once a texture is removed, detexturized, you get a new image. Once you decolorize, you get a new image. Once you enhance the images in the same image, you get a new image. So using single image, and I can apply several transformations to create multiple images. This is the whole process of data augmentation. It comes in handy, especially when you have less data. You can create a lot of additional data by not by just applying these transformations. And so this is about data augmentation. Again, in data augmentation, you can accomplish it using several, see, there are a lot of external packages available for data augmentation itself. But in TensorFlow, we have a couple of packages. One is Keras pre-processing layers, and the other is the TF image. So if you take these two packages, the TF image is a better one compared to the Keras pre-processing layer. So I'm going to just do a simple transformation here, but there are a lot more transformations which you can do for this particular use case. But I'm just, for the sake of simplicity, I'm just keeping it simple. I'm using TF image API. So this is my augmentation pipeline. So I'm writing a class where I'm just doing a random flip left, right, this particular transformation on the image to create a new image. So this is how you can use. You can go to the TensorFlow documentation to learn more about the TF image by API. So this is, we've come to the end of data augmentation, building input data pipelines. We have seen what is TPUs. We have also seen what is TF records and all of it. And now we're going to the modeling part. So modeling part, as I already told you, we are using a pre-trained model called EfficientNet. So again, in this particular notebook, you have a link to the research paper of EfficientNet, which you can go and read further about the architecture and all of it. You have a research paper here linked at the bottom. So if you can learn more about the EfficientNet architecture from the paper, a little gist of or intuition of what is happening in EfficientNet is See, most of the predecessors of efficient.net, not all, most of them have used one form of scaling. Either they have scaled the depth or width, or one form of scaling they would have done. Resolution, one of these parameters, they would have dimensions, they would have scaled it up. But efficient.net does scaling of all three dimensions, depth, width, and resolution. And so it is able to scale all the dimensions uniformly by using some compound coefficient. And how this compound coefficient is derived is there is some constraint. So for example, depth, is controlled by a parameter called alpha, and width by beta, and resolution by gamma. There is a constraint like alpha dot beta square dot gamma square should be equal to 2, and both alpha, beta, and gamma should be, all three should be greater than 1. There is some constraint. But using given these constraints, you have to find, using grid search, a compound coefficient which will uniformly scale all these three dimensions, which is depth, width, and resolution. It might be overwhelming if any of you here do not have basic background of computer vision. It might be a little overwhelming, but don't worry. If it's going to be your first time, it's completely all right if you don't get it. And so this is how this is the principal concept of the efficient.net. And efficient.net, the base architecture is determined by, they determine the base architecture using a technique called neural architecture search. And so efficient.net, this compound scaling method, it's not it is proven to be effective when applied on multiple other architectures as well. You get around 2.5% increase in the accuracy by using such compound model scaling. And there is also statistics given here. You can see at this time when the paper got released, there are all the predecessors performance and efficient.net performance plotted in the graph here. It clearly visible efficient.net was outperforming all its predecessor at the point when at the time when the paper got released. And so then this is about efficient.net. And so here we are using transfer learning, we are taking efficient.net, and we are taking the, we are freezing most of the architecture, and the final layers, we are just the classification parts. We are just, adding few more layers. We're adding a global average, pooling, dense, dropout, and dense. We're just fine tuning this efficient.net architecture to solve this use case. And just next, the other steps are going to be easy. Optimizer, Adam, loss, binary cross entropy, metrics, and all. This is how you apply transfer learning to solve a problem. And then once you build a model and then you're going to train it, you're setting all these parameters, and then you're training the model, and then you're making a prediction. So this is how very brief introduction to the solving the particular Kaggle problem using TensorFlow APIs. And we've come to the end of the session. And there are a lot of other things which you can, this is just a baseline solution. If you want to learn more about it, then you can go to the discussion tabs here. You can check out, if you're already very familiar with all these terminologies, then you can go to the discussion forum. You can ULab solutions, first place, second place solutions. You can check out the winner solutions, and that might give you a better understanding if you already know TensorFlow and all. So this competition also had a huge shakeup, and a lot of people from behind the leaderboard came to the first place and all that. So this is about the end of the session. So if you have any questions, you can let me know.
Yes, anyone have a question can raise your hand and we can unmute you. Meanwhile, Usha, can you get back to the notebook and show them the learning rate scheduler that you do, a warm-up learning rate, which is, I believe that you doing this stage for when you're working with TPUs, to also it will help you to not get into some kind of overfitting or sticking in a local minima. If you like to describe it for them, yes.
Yeah, this is a custom learning rate scheduler which I have written. You can also use the learning rate schedulers available as a part of your TensorFlow ecosystem as well. So this uses something called cyclic learning rate. So cyclic learning rate, if you want to learn more about cyclic learning rate, I've added a research paper on why it is very efficient. So here you have the learning rate max and you have the learning rate minimum, and so these are the parameters which are available for you. So there are different kinds of learning rates. So you have something called step learning rate, multi-step learning rates, and you also have exponential learning rates. So each of these learning rates, most of the objective here is to keep reducing your learning rate. So how do you reduce the learning rate is what differentiates across these schedulers. So if you take a step learning rate, you have, at each particular step, maybe like you give a certain constraint, and until these many epochs you should have this kind of a learning rate, and after that number of epochs is crossed, you might give a factor which you will multiply with the learning rate, and then that will be the learning rate for the upcoming epochs. So you will have some factor and you will keep reducing your learning rate for certain number after every number of epochs. And the same thing multi step learning rate also, but then there it's going to be like you're going to reduce your learning rate after some milestones. So the same way, the differentiator is how you're going to reduce your learning rate, and this is what is differentiating between the different types of learning rate. So cyclic learning rate uses this term called superconvergence, and it has a maximum and minimum value. And how it is going to reduce the learning rate is what is this particular scheduler. You get certain parameters, and you find the LR max, and then you have a function to take care of your learning rate, how you should decrease the learning rate values and all that. So this is what is the crux of custom learning rate out here. You can go to the paper and you can learn more about cyclic learning rate and this phenomenon of super convergence and all that. This is a research paper which explains it in detail.
Yeah, thank you. I guess this is a good answer for this, for those that was not using any learning rate scheduler, which is a way that we can override some learning plateau and sticking in a local minima. There is a lot of discussion in this area. And thank you for this implementation for cyclic. I guess there is the guys that has raised them hand. You can just unmute yourself, Zahra.
Thank you. Can you hear me?
Yeah, I can hear you well.
I actually have a question regarding the first part of the presentation. First of all, thank you very much. It was quite lovely. Although I don't have that much of a background in machine learning in general, but I quite enjoyed it. I wanted to know whether you put the metadata that you mentioned earlier at the beginning in consideration when you classify the images. Are they taken in consideration when you diagnose the person, like their age, previous, like if they have a family history with melanoma and so on?
In the notebook which I've used, I've not used any metadata, but there are some sample notebooks out there which uses the metadata. If you go to the winning solutions, they would have used the metadata as well. Almost all the winning solutions that use the metadata, and they've converted that into as features, and different people have handled it differently. But I can just take one notebook which might have used. So you can go and check out how to use the metadata. You can check out from one of the winning solutions. You have second place solution
Mhm.
overview and all that. So you also have first place solution with code. So the code also is available. So you can actually check out their solution. For the sake of simplicity, I've used the metadata or not. But I think the winning architectures have used it in some form or the other. They have given, I think you'll find at least top 100 solutions you'll find at
Mhm.
a leaderboard, and you will have the entire code also. So the code is available here. So this particular person is the second place. So yes, put the code here. And he would have, I mean, most of them will have an architectural diagram which explains how they've used it. He has not put the architecture, but most of them will have an architecture diagram and all that. So they will explain how they use the metadata. So MLP for metadata. So this particular first place challenges use the metadata, and their code will be there somewhere. So this is the PyTorch code. So this is one code where the metadata is used. I'm just sharing it for you.
Thank you.
You can go and check it out later. Do you know PyTorch?
Excuse me.
This code is written in PyTorch framework. So
I will check it out and see if I have any.
yeah,
Um,
sure. You can check it out and see.
Thank you very much. And I have another question, if I may.
Yeah, sure. Please.
Regarding people of darker skin color, because I saw the images that you used as samples in the notebook that you've shared, and I mean, are people of darker skin colors of skin color are taken in consideration when you run your when you try to figure out the diagnosis, let's say,
Yeah,
like
I think it is taken into consideration because I have not explored the data set completely. The data set is coming from this organization called ISIC. And
yes.
so this is an international organization, and they care a lot about, the ethics of using data and all, especially when you build a model in the medical field. It's very important that, you should take into consideration about the darker skin. So the data set which they have prepared, I think if you go to their official website, you will find more information about how exactly the data set is collected. So I can share. Yes, I see. So they maintain a huge repository. So
Mhm.
ISSC, so they will have an explanation for the data set, how the archive has been collected also. And so this is the website, which is ISIC. And
Mhm.
so the constraints and all that they would also mention here. So the download data and participate in the studies, explore collections of high quality image data sets, learn about the ISSC project and goals. So you have details about you should have details about the data set, because since this is a research organization, they'll be very particular about how they had collected the data and all that. So I think the information which you're seeking should be somewhere here. They should have taken into consideration as well as what is, I assume, but I've not checked every single file which they have. But if you can dig through this website, you might have,
Uh-huh.
solution on how they
I'm
exactly collected the data.
great because I mean the first thing that came into my mind that the scarcity of pictures that contain people of darker colors might affect the outcome.
Yeah, that's going to be very important. I definitely think they would have, taken that into consideration, and across the different race and ethnicity, they should have collected the data. But exactly, this is the research organization website. Exactly how they collected the data will be there in this particular website. If you can go dig through this website, you will find exact answers to it. And yeah,
Thank you. Thank you very much.
yeah, welcome.
Yes, I guess there is another one raising your hand. Please unmute yourself if you have a question.
Hi. This is Vishwajit from India. Actually, ma'am, you have shown a really good notebook, and that is really helpful for reading in the computation of Kaggle. So, like in machine learning models, like the models like CatBoost, LGB, and XGBoost with status ensembling and like many other methods. They do help a lot in machine learning models or maybe in computation to lead in the leaderboard. Like for like, I want to know the crux in image computation. Like, what is the like what is the threshold or what is the like the model that we can after that we can like what are the what is the base model that you can start from for any kind of image classification model computation in Kaggle?
I think right now EfficientNet is doing well if it is an image classification problem, and you can also try VIT Vision Transformers. I think Vision Transformers are doing extremely well in the leaderboard and for most of the image classification problems. And if it is going to be an object, vision has got the other kind of problem statements as well. So you have object detection and all. So if for object detection, YOLO architectures are doing good. And I think recently there was again a competition from SIIM as well. And so there were several other architectures. This year there was a competition from SIIM, the same thing, but that was related to COVID. So yeah, you have this particular competition, which was this year's competition, which just got over. So you had this was an object detection competition. So you can go and check out the architectures, which had one good scores in the leaderboard. So
Ma'am,
Yellow Detectron, YOLO V5, and all these things are doing good for object detection. So I think if you're dealing with image classification, you can get started with EfficientNet, which could be your baseline notebook, and then you can keep reading the research papers which has come out recently and try experimenting. But I see a lot of winning solutions using EfficientNet and VIT as well. And so that could be your baseline model to just start your experimentation, and then later on, read research papers and improvise about that.
and ma'am, I do have another question. Is that like over here you have used a patent like model of efficient. So my question is that like suppose like for this data set it worked very well actually. You had done a lot of hyperparameter tuning and after that you have come into the conclusion. But the thing is that suppose like for suppose the pretent models doesn't works very well in well in many of the competition I've seen that P10 models are not because and many of the winners are like tweaking the model like they are changing some kind of architectural in the model structure. So like for that, what would be your advice on the changing the architecture? Maybe like tweaking the model, not changing the architecture, maybe tweaking the model somehow.
Yeah, tweaking the model, I would say it requires a lot of computational resource, and so you need to have good GPUs and things in ready, because the Kaggle gives you only like 30 hours to 40 hours of GPU.
Yeah.
And so that is a constraint available always. So good GPU, either have cloud credits or so most of the times, even for tweaking the model and stuff, in most of the Kaggle competition, the codes are actually released. If you see, they would not train all the number of epochs for a single Ford. For 2 3 epochs they would have trained, and they would release their code. They would say this is the architecture they're using, but they'll not, they wouldn't have trained for 30 40 epochs, and they wouldn't have thing. But the most of the competitions, if you go and see, if you're a beginner and you can actually check out the notebooks which is available under the code section. Most of them would have released the code, and so that is more than sufficient for you to get started. But using that code, if you want, they would have just put 2 3 epochs. But if you want to train for a lot more epochs and increase your performance, then you need to have good GPUs. And or if you're part of some communities, you might get free cloud credits and things like that. So I have not personally experimented much with the architectural tuning and all. I've just used most of the competitions which had won medals also. Whatever architectures were released in the notebook section, just experimenting and doing some ensembling of various architectures itself had improved my accuracy a lot. And a lot of competitions where I had won the medals, I had just got those medals using the public notebooks only. Nothing much. I did not come out and no out of the box solutions. This was the case for Cassava competition as well, but that competition we did not win the medal, but we were in the top 15 or top, we were in the top zone, due throughout the competition we were in the top 20, top 30, but there was a lot of shake up and we did not win the medal. This competition happened early in this year, around March or something it got over. So if you see the Cassava competition, the second place winner used a model from TF Hub. He did not use any. I'll take that competition and show you Cassava. This cassava leaf disease classification, the second place winner, he just used a TF model. And even he had put, no, he had only tried it 2-3 times and he won the medal. So, and he's a novice, he was not a very expert Kagler and all that. So it was a shake up. So he came 658 and he is a novice and he just in 3 attempts, he was able to get the second place. So he just used a TensorFlow TF model. So, this competition, we just used the codes which were released in the notebook section. That was more than sufficient, just performing small, changes about that. And that was more than sufficient for us to get on good position on the leaderboard. So I did not try anything out of the blue for any of the competitions. And maybe sometimes you can read some research papers and the codes for the research papers will also be released. So for every competition, if you go to the discussion forum, there will be like some people who would have put, the research papers related to this competition. You'll find some thread like that. So here also research papers related to so you can click on these research papers and most of the research papers will have a corresponding code as well. So you can go and try adapting those codes to your particular use case and you can experiment with that. That is also some form of experimentation which you can try. And this is what I would suggest, on how I tackle problems. Yeah.
Thank you, ma'am. That's all. Thank you.
Yeah, no, thank you. This was awesome. I have a couple of questions that's outside this competition, if I may ask you. Since you are an experienced data scientist, firstly, in our group, there is a lot of those who in entry level, and when they want jobs, and I have a lot of email regarding this, how they could build a good portfolio or a CV so they can land their first job as a data scientist. What thing that they have to put in CV or what project they can go into? This is my first question, and I will ask the second later. Yes.
So to build a portfolio of projects, most of the recruiters whom I'm seeing, the lot of people. One thing which I notice is they do a lot of certification courses. It's good to have all these certification courses, but what recruiters actually look for is, are you able to apply this theoretical knowledge which you learn from the course to solve a real world problem? This is the skill which they are looking for. And so you need to find some unique projects in your resume. You need to stand out from the crowd because data scientist job is, now the space is getting overcrowded. In India, the statistics is like we have like 5 to 6 openings and there are like 1,300 people applying for it. So the huge number of people applying for very few openings. And so it's very important that you stand out from the crowd. So a lot of resume mistakes which I have noticed while I was hiring is a lot of people put the MNIST data set, which is like, a very toy form of data set in computer vision. And, they put Titanic and all these as projects. This is a huge mistake. Please don't put such projects in your resume. You have to find out some unique projects which will make you stand out from the crowd. And so Kaggle can be also a very good resource for the projects. If you're not, if you're in a different, a lot of people whom I see, they are in a different stream currently. They might be business analyst or something like that. They want to transition into data science. So they wanted some real world experience. So that way you can take some complex Kaggle competition projects, and you can also work on it, put your end-to-end solution in GitHub, and deploy it as a web app using, you can use any Flask or some of the APIs to deploy it as a web app. And you can put the source code in your, you can build an end-to-end application. For example, even melanoma classification, you can build a web UI interface where you give an image and you get the output immediately. The UI will show you whether the particular image has melanoma lesion or not. So some kind of an end-to-end application you can build, and you can put the source code in your GitHub. And you can take some unique projects. So not very basic projects, take some unique projects. But Kaggle is putting you can participate in Kaggle competitions, and if you can place on the leaderboard and put that experience, that will stand out. Or you can also look through your surroundings. There are a huge number of data sets available out there in data science. So there are a lot of people who have open sourced the data set. So if you take your society, any particular, if you take the societal problems, there are a lot of problems which will be there, which you can try to solve those societal problems and put that as a project. Then that will stand out. For example, in your particular district, there could be some problem with the water commission, or the police department might have certain problems, or the government bodies might have certain problems. And so all these problems, you can go talk to these governmental agencies and tell them you have good expertise with your data, and you can work for free, because this is going to be a side project. So you can tell them you'll volunteer for free work. That way they'll give you access to their data sets, where you can also help them with solving their problem. At the same time, you will also get some experience in your resume as well. So a volunteer for several organizations, the society, there will be like a lot of organizations which are working, NGOs, which may not have enough money to pay you, but they'll be working on very important burning issues like child trafficking and all these very burning issues. So you can volunteer to them and help them analyze the data, and solve some of the problems which they are facing. That these are some of the projects which will stand out. And this you can do. And if you feel you don't have enough bandwidth to go reach out to these organizations and do projects, then you can actually use Kaggle as your projects. And but if you're a master student, or if you are somebody who has just finished your graduations, look out for internships. And those internships projects also can be add a very good value to your resume. So the projects is something which should stand out from the crowd, and it should be something which demonstrates your skill. Like, it should be a bigger problem statement, and not very toy problems like Titanic and all that. These are some things which you need to pay attention to, not just projects. There are a lot of things which you need to pay attention in your resume. Like, do you have public speaking experience? Do you write blogs? And are you a YouTuber or something like that who has done a lot of videos? How have you contributed to the community? That is also very important, because they're looking for factors which will make you stand out from the crowd. So building a community like Kaggle Days, or building a community like Pi AI machine learning groups, or all these are additional extracurricular activities which will add a lot of value to your resume. Community building is a great way. And so try to engage in a lot of public speaking activities, write blogs. And so these are also these things will add a lot of value to your resume, because companies these days are looking for all rounders who have got good community engagement skills and things like that. So it's very important. And so these are things which I would suggest based on my experience in hiring candidates in India.
Okay, thank you. Thank you so much. My second question, if I may ask it, yes, is that that's the field of machine learning is fantastic, and there is a lot of applications, and even in research and academia, also related to industrial. So there is, I've seen a lot that though maybe working on computer vision, then founding a project in natural language processing, then jump into different kind of medical problem to solve. Is this a good approach to learn, or you have some advices to those that to stick in a specific domain so they will build a level up knowledge instead of shifting from field to field? I know that most of the algorithm will be reused there and there, but the knowledge in the domain I have seen is very important. So when you're working in computer vision, there is some kind of knowledge in image processing that will maybe help you. So when you're reading in depth, and it will help. While when you jump in natural language processing, you can use the same models, the same algorithms, but there is also a need for a knowledge in domain. Or you seeing all this kind of task is doable, and someone can jump from there to there in any time. Yeah.
Yeah, sure. Personally, in my experience, I would always recommend people specializing in one particular field. Specialization is what will pay you high. So, like if you specialize in NLP or specialize in computer vision, that would add a lot of value because people want specialized people and not people who know everything. If you know everything, then that's great. But if you are very strong in a particular field, that's what will add a lot of value to your resume. And to be very strong in one field, you require a lot of focus. You should have undivided focus, and it also depends on the bandwidth you have. So for example, if you're just a student or if you have taken a break and you have a lot of free time 24 hours a day, then you can practice all three domains and you can become an expert in it on all three equally as well. Because as you said rightly, once you are familiar with PyTorch, and you know the end to end how you apply deep learning in PyTorch, deep learning in computer vision. There's a lot of things which will be the same when you apply for NLP as well. Most of it will be the same. There's at least like 70% to 80% of the knowledge transfer applies for NLP when you take deep learning for NLP in using Python. So there's a lot of things, which will be like, very familiar for you. And the basic machine learning is also easy. But one thing which you need to really be careful is how do you ace your interviews. So when you go for interviews, if you are specialized in one particular field and very strong in it, because interviews will be very tough, and they'll ask you to derive a certain probability. They'll give you like certain probabilistic theorems or like certain things, and they'll ask you to write Python code to implement this particular hypothesis, or they'll take this there's a course in MIT probability and statistics. So it depends from companies to companies. Certain startups, when I hire for startups, certain on behalf of certain startups, I just look at their GitHub profile, and I give them a small task. If they finish those tasks, then I just hire them, because we want candidates very quickly in 1.5 weeks or so, and there's a very less time. So there's not much of time to do that kind of an in-depth hiring and all that, especially. And mostly I hire interns, and I hire like third year students who are doing engineering and things like that. So but it's going to be very different when it comes for a bigger company or a very standard company. Then the hiring process is going to be very different. You will have 5 to 6 rounds, and some of the rounds, the first few rounds will be coding rounds where they test you in data structures and all that. Even though data science, you may not be using all those things, data structures, and you're going to use a lot of libraries, but the first 2 rounds will still be a programming round, and they'll test you in linked list trees and all that. And there'll be several domain rounds. And this is where, if you're just specialized in one thing and you say, I'm strong in NLP and all my domain rounds has to be in NLP, that's a very good thing. You can just put some 1 month of preparation and just one domain, it's easy to learn. But then if you're going to specialize in multiple domains, an interview is going to be very difficult, because you should be like knowing in and out. They could get you any concepts, and ask you to like write Python coding for a particular algorithm from the scratch. So preparing for interviews can get extremely difficult when you're specialized in multiple domains. So again, it depends on how much of time you have. If you have a lot of time, then focus on all the things, know everything at the basic level, and take one domain, specialize highly in that. Or if you have very, very less time, then just focus on one thing. Find out, try solving some basic problems in NLP, computer vision, and classical machine learning. Find out which is something which interests you a lot, and just focus on that one thing if you have very, very less time. And practice, practice a lot of real world problems. And Kaggle has got huge repository of, for over the period of 10 years, last 10 years, there are several computer vision and several NLP problems out there. So you can use that as for practice and be very strong. So it is once you clear the interview, and then you may not require all the theory and all that, but to clear the interview you have to know that MIT level probability, MIT level statistics, linear algebra, and all these things are very important. Mathematics is very important for clearing interviews for standard companies. Again, in early stage startups, they're not going to do that kind of an in-depth. Some of the startups, they may not do that kind of an in-depth training, asking you to derive equations and write those equations and code. That kind of so extremely difficult interviews is not going to be there for early stage startups, but for very standard companies that could be the case. So this is something which you need to take into consideration, and what you want to do, what kind of companies you're targeting, and all those things when you venture into learning all three domains. So this is just my advice. So yeah, you should try out what works for you.
Yeah. Thank you. Great answer. I think there is Dr. Yasser. I may ask you if you want to. You raise your hand. You want to?
Hello,
Yes.
everybody. Hello, Mr.
Hello.
Al-Ma'mun. Do you hear me? Sorry.
Yeah, I'm able to hear you.
Hello. Yeah, thanks for the nice session. I'm Dr. Yasser from Basra in Iraq. Actually, I'm assistant professor at the university and head of the Department of Communications Engineering. So actually, I have a PhD in telecommunications engineering, and sometimes I have when I read about data science, because I worked on statistical modeling. Usually, what was my work is about we have the communication channel, and actually we work on the statistical modeling of the communication channel, whether using the same like regression techniques or other techniques like what is called geometric techniques and other correlative techniques for massive MIMO and size, so the single input, single output channels. We usually use MATLAB in doing our work. So actually my question, actually we can like two questions, but I can mix them in one question. That in MATLAB, like I see because I have the intention sometimes to work as a data scientist or focus on this field, because maybe I have in the future the idea of working remotely. So I can like have different places when I live, I can work on remote jobs. For MATLAB, what do you think? I don't see like many openings they focus on MATLAB. Now I saw that very nice talk that you said that you focus on something, but mostly my work is on MATLAB. I have, of course, the statistics and the modeling theory, but actually my focus on MATLAB or Octave, which is an open source. But I have knowledge in Python, not that much, and others, but my focus mostly on MATLAB. So do you think this will be good for the future if someone wants to work on data science, or I need to focus on Python or R?
Um,
Thank you.
I would recommend, based on the job openings which I see across geographies. I've also worked with startups in US, Canada, and other countries as well. Based on the job openings, I would say Python might be a safer choice if you're considering data science. And because data science really has lots and lots of jobs, remote jobs, and so there are a lot of clients for us who are based out of US, and we work remotely for them. So data science is an ideal career for you if you want remote jobs. And if you want to focus on a lot of, generally when it comes for job search, we apply for a lot of jobs, and then we might be getting selected in few of them. So when you want, the number of openings are huge for Python. And whereas
Okay.
for MATLAB, there are limited number of openings, but there are very specific, specialized, highly specialized openings available in certain companies, but they are very limited. And so it sometimes whenever there's a limited number of openings, that's always very difficult hiring, because sometimes if you have just 2 3 openings, what if somebody in the company itself recommends some of their friends and
Yes.
relatives? They have high probability of getting selected. Reference plays a huge role. And there are huge companies, especially when you take up automobile companies and several other companies. They extensively use MATLAB for data science. There are some very very big companies which still use MATLAB for data science, because I'm able to say this. See, I have not personally worked on MATLAB, but I've worked, I've collaborated with the company called MathWorks, because last year we
Yes.
organized this new IPS India meetup, and I organized with the MathWorks India. And I also hosted MathWorks employees for one of our meetups. I can share the meetup link with you. And so in this
Okay.
particular link, if you just, so he is actually explaining how, data science can be, one of the explanations is how data science can be used for, several of their applications and clients, how they are using MATLAB to solve the problem. And these are MathWorks employees based out of India. It is there on my YouTube channel. I'll just take that video for you. So they have some standard customers for them. They have like huge companies are still using MATLABs. But most of those companies, the hiring positions might be through referral, and getting into the very limited openings might be there, one or two data scientists. And it all depends on the luck, and there are several other factors for those limited openings. But if you're targeting, and what is the guarantee those companies, if it is a very bigger organizations, how comfortable are they in giving you a remote job? If it's going to be a
Yes.
startup, they might be open to giving you a remote jobs very easily. And because they don't want to cut down on the infrastructure cost and all that, they'll be open to you working remotely. So there's a lot of factors. So my best advice would be to learn Python. Python is going to be very easy. And so you can learn it, if you can take a break of 1 month, and you will be able to, since you have a PhD and you're a professor and all that, it will be like very easy. You will be able to get the concepts very easily, and I can share some resources for you, the best resources to get
Okay.
started very quickly.
Thank you.
In a month you can pick up all the concepts, and you can also get some real world exposure with some projects in Kaggle as well. And the particular talk from MathWorks
Okay.
is should be here. 1 minute.
I can focus or just on Python. No need also to focus on R, right? Because in this
Don't
case,
focus
as you
on
said,
R, because R, I think that it is the the familiar importance is coming down a lot. Companies are moving towards Python, and very
I see.
companies are using R. And this is wait. So this is the thing.
Okay.
So these are MathWorks employees from
This
India.
session
So you have
will introduce you to concepts of machine learning and deep learning.
so
And
this
we have two
video you have Shayani Datta and Amit Doshi, both from MathWorks. They are just showing a demo of how MATLAB is used in a lot of companies. There are huge companies, billion-dollar companies, all using MATLAB only. And
Yes.
but the number of openings there will be limited, and we don't know the factors which will influence those openings and things like that. So if you're targeting startups and huge a number of openings, then Python might be a safe bet for you, and it's a very easy language. And
Yes, it's also interpreted language. Actually, when I see that, it's just even the function definition. This is okay, you know. I took a look at it. But the other question, is about when you see these openings, you will see that actually they don't focus just, let's say, Python. They say, okay, you have data science, can do this. Then programming languages, Python, Scala, R. They add many languages. Do they mean that they want the person, as you said, that general know all these languages, or they mean that any one of these languages, any language of these? Do they mean that one specific language? Because they put many languages usually, if you see in the openings, R, Python, Scala, Julia, many.
so amongst the Python, MATLAB, R, Python, Julia, you just have to know Python. That's more than sufficient.
I
And
see.
they will put like that only in the job description. But during
Yes.
the interview, if you're extremely, comfortable and confident, then you can actually, it all depends on your negotiation skill, how you turn that interview favorable for you. So Python is more than sufficient, but when you come for big data engineering, most of the companies will expect good knowledge in cloud. So get yourself familiar with AWS or GCP, or Azure, one of the cloud platforms. Get yourself familiar. There are a lot of quick lab notebooks. You
Yes.
just have to spend 3-4 days. It's going to be very easy. See, if you've completed PhD thesis and all that, this is and all is nothing, like very simple. You in a day you will be able to understand in and out of it. And
Actually, Miss, sorry if I cut you, but actually you mean that no need to have these certificates of AWS solution architect, and there's no need. You mean just I get the important information in
you just
some
have
days,
to
that will
know
be
the,
enough.
yeah, that most of you just have to know how to deploy your models in cloud and how to operate through these platforms. That's more than sufficient. The
Okay.
second thing is, this is about the cloud. The third thing that you need to know is some of the big data engineering technologies. So deployment at scale is very important technology, where most of the companies test, I expect you to know Spark. You don't have to know everything. See, if you take deployment at scale, there are a lot of architectures out
Yes.
there. Spark, you should, they'll expect you to know Kafka, know a lot of things, but you don't have to know everything. Just learn one thing, but that one thing you be very thorough in it. Then interviewer ask, you can say always, "Okay, see, I know this thing, so I am very confident I'll be able to pick up a similar platform like that." Like that you can say. But
Okay.
in one thing you be very strong, and this big data engineering and all, for you take choose Spark, and for Udemy has got good course. Choose a course which is like 4 hours or 5 hours long with hands-on experience with projects and all. You have find it in Udemy, and
Okay.
that is more than enough. You will be able to finish it off in a day, and
Great.
you can revise it for 2-3 days, the same videos, watching it over and over again. You are all set for an interview. Just learn one big data engineering, and one of the NoSQL databases some companies expect you to know. So NoSQL databases, again, there's a huge number of databases like Cassandra and graph databases and all. Just learn one thing. One database which I would recommend is MongoDB. So again, if
Okay.
you see, you can just learn Python, be familiar with cloud and Spark. You can stop with that. The reason is you will have an edge over the other candidates in a way that you have a PhD degree, because not many candidates have PhD, and for certain research level positions, they specifically look only for candidates with PhD.
Okay.
So that way you have an edge over the other candidates. It's not necessary you should know everything. Just learn three or four. One is Python, be familiar with the other TensorFlow, PyTorch. Then Spark and all. In there are 4 hours, 5 hours videos available in Udemy, which you can finish it off in a day, and you can revise for 3-4 days, check out few interview questions. That should be more than enough. And those are all, like, they'll tell you step by step what to do, and you have to do it. That's it. It's like not a
Great.
thesis or research paper. That is going to be very easy. So you just take a month off, and
Okay.
prepare for it. You will be all set for a data set interview. I think when you have a PhD degree, you have an edge over the other candidates. So you have higher probability of getting a job, and you also have higher probability of getting a higher package also. So for a PhD people, the package is very high in most of the companies. because they want somebody who will be able to have a stronger mathematical foundations, and all these things is their expectations. So I think you have a bright chance of getting a very very well paid job in a remote
Okay.
job. The chance is very high. Pursue it strongly.
I hope actually, and there is this one company. It's named Turing. I don't know. Sometimes I get the like advertisement Turing, Turing. This one is a big company. Like they say they found remote jobs for um, the people who have skills in U.S. companies, something like this.
Oh, I'm not sure of these agency. I've not heard of Turing, and I'm not sure of it. But generally, I'm telling you, you can approach the startups directly, for find out the
Mm.
startup founders, and connect with them on LinkedIn, and you can start speaking to them directly, or their email ID. You can, if you have mutual friends, ask them to look up their email ID, mail them, and the company website will have email IDs as well. And that's a better way to reach out to the startup founders. I have found 80 to 95% of the time startup founders replying to me very easily. And
I see.
so you have higher probability of connecting to a person directly. And so don't trust any mid-level agencies promising,
Okay.
some agencies in US. I got to know from my relatives out there. They say, you give the certain number amount of amount, and we'll promise you a job, things like that, and you have to
I see.
deposit in few days. Or be very cautious of it, and be
Okay.
very careful about such things. The best way I would recommend is don't fall prey to certain kind of organizations like this. Just approach directly the companies. And the fact that you
Okay.
have a PhD and you're a professor, you have 100% of chance the startup founder will accept your LinkedIn connection, and you have higher probability of getting a job as well, is what I would
Okay.
say.
Okay. Great. Thank you. If it's okay, I will also contact you on LinkedIn if I have any other questions.
Sure, sure, sure.
Thanks. Thank you. Thank you very much.
Nice. Usha, very thank you for your kindness and your answers. I have a question from Dr. Bashar Al-Isawi, but I'm just going to get back to Dr. Yasser about something that MATLAB, it's more power used in factories with the digital twins, this kind of thing that you done by Simulink, and this digital twins that built by MATLAB is some kind of skill maybe is can give you advantages. But I don't know about remote work, but I know some friends, they are specialized in building digital twins and working with MATLAB in large factories, and for those who talking about MATLAB. But getting back to MATLAB, Dr. Bashar Al-Isawi saying that is MATLAB provide AI capabilities similar to those for libraries like TensorFlow or Caffe or PyTorch that's been built and to help you accelerate and work based on GPUs and build your own graph and build a powerful neural network and such kind of things. Yes, this is a question for you, Usha.
So I think MATLAB has got higher set of features to perform everything which the current deep learning frameworks offers. Is what I got to know from my friends in MathWorks, and but I have not personally experimented the framework. But I've just got to know from my friends they have much more higher capabilities compared to the TensorFlow and the PyTorch framework. They have much more advanced capabilities actually. So when you go for a research organizations or a huge billion-dollar automobile companies, at that kind of a scale, you require certain higher processing features and capabilities which MATLAB offers. But it may take a lot of hard work to get those features in TensorFlow and PyTorch, is what those people told me. But I've not personally worked in MATLAB, so I may not be the right person to comment. But if you see, this workshop is being conducted by Ahmad Joshi from MathWorks Pune, and the Shayoni Datta, she's also from MathWorks India. And you can actually contact them in LinkedIn, and they will be able to help you out and give you much more better clarity, with regards to the MathWorks capabilities and stuff. And so, yeah, this would be my answer. Yeah.
Yeah, thank you. Thank you so much for your answers. I don't know if there is other that who have a questions, and there is no one raising his hand. Uh, I think that if, so we are not going to take much from your time. I really appreciate that you are here and that you part of our community as a Kaggle Days Meetup Iraq. That this is the third version, and it was a great workshop with a very famous and a bright and smart Usha named Tensor Girl. Thank you so much for your time. Thank you so much for answering all these questions, and hope we can see you in next versions. And also we organizing by an AI Iraq. This was the a week ago. We making our first edition, and think maybe I will contact you for my newer version. I will always be depend on my friend, and you are a good friend for helping us in building this community and sharing the knowledge. Thank you so much, Usha. And if you have a final word, that would be appreciated for you. Thank you.
Thank you so much for inviting me, and it's my pleasure to be part of Kaggle Days Meetup Iraq. I really enjoyed my time answering the questions and doing this presentation. I do hope you enjoyed as well. I would love to do future meetups as a part of communities and events you organize, and maybe handle different kinds of problem statements and different data during those workshops. And you're doing a great job in bringing Kaggle Days Meetup to Iraq, and organizing deep learning.ai meetups as well. It takes a lot of effort and hard work. I've been an organizer myself. I organize Google Days, Google developer groups in India, and I organize Google developer groups meetup. And I'm also organized TensorFlow user group meetup. I built one of the biggest communities for TensorFlow user group in India. So I've organized all these meetups, and there's also another community called Women in Machine Learning and Data Science. I'm also an organizer for a couple of cities in India. So, as an organizer, I know it takes a lot of effort,
Yeah.
to organize events and bring in speakers from other countries. These are like a lot of effort.
Yes.
In addition to your full-time job, if you're able to pull it up, and that's like a lot of dedication to the community. Keep up the good work, and keep doing great work. Wishing you all the best, and wishing everyone who has attended the meeting a bright future, and may all your dreams come true.
Yeah, thank you. Thank you so much. And thank you everyone for joining us. And this is the end of our workshop. And we'll see you in the next workshops. And thank you everyone. Have a great day. Yeah,
Bye. Have a great day.
bye. Have a great day.